Hello everyone, in this video we'll be discussing about Azure Container Registry or ACR. So Azure Container Registry is a managed registry service based on the open source Docker Registry 2.0. And this helps you to create and maintain Azure Container Registries to store and manage your container images and related artifacts. So why are we using this container registry? We have some use cases. The first one is to pull images from various deployment targets, so that you can pull the Azure Container Registry, pull images to this Azure Container Registry from various deployment targets like scalable orchestration systems and Azure services. So we can pull the images from Azure Container Registry to these targets. Scalable orchestration system means like Kubernetes, TCOS, Docker Swarm, etc. And Azure services include AKS, Azure Kubernetes Services, App Service, Batch, Service Fabric, etc. Then we can also push images to a container registry. So we can push the container registry as a part of our development workflow. And like for example, there is a target container registry from a CI/CD tool such as Azure Pipeline or Jenkins. We can push that image to a container registry. We can also configure ACR task to automatically rebuild application. So this ACR task can be, or these are called Azure Container Registry tasks. These are used to streamline building, testing, pushing and deploying images to Azure. Or you can also use multi-step tasks. So multi-step tasks are used to automate this building, testing, patching multiple container images in parallel in the cloud. So there are three tiers of Azure Container Registry. First one is basic, then comes standard, then we have premium. So basic is the cost optimized one. So cost optimized, so it is for developers who are learning about Azure Container Registry. So this is most appropriate for low usage scenarios. So standard is same as basic, except that there is increased storage and image throughput. So this one is used for production scenarios. Then comes premium. Premium has got the highest storage and image throughput. So it also has geo-replication, and also we have image tag signing. This is for security. Also we do have a private link generation so that we can restrict the access to this particular registry. When images are grouped in a repository, each image is a read-only snapshot of a Docker compatible container. So Azure Container Registries can include both Windows and Linux images. Azure Container Registry tasks are used to streamline building, testing and pushing and deploying images to Azure. Then let's explore the storage capabilities. storage capabilities of Azure Kubernetes Registry ACR. So all Azure Container Registry tiers benefit from advanced Azure storage features like encryption at rest and regional storage, geo-replication, zone redundancy, and scalable storage. So what do you mean by encryption at rest? So encryption at rest means that all container images in our registry are encrypted at rest. That is, Azure automatically encrypts an image before storing it. So encrypt, and then we will be storing the image in the registry. And when it is decrypted on the fly. That is, when your application or services pull the image, it is decrypted. So when you pull, it is decrypted. Regional storage means that Azure Container Registry stores the data in the region where the registry is created. Why? This is to help customers to meet data residency. This is for data residency. So in all regions except Brazil and South and Southeast Asia, it is available except in Brazil and Southeast Asia. Okay, Brazil, South Asia. Except these two regions, you have regional storage or data residency. And also Azure can store data in a paired region in the same geography. For example, in the Brazil South and Southeast region, data is always confined to the region to accommodate data residency. So except for these two regions, every other region you can have a paired region where this data is also stored in that paired region as well. So that if a regional outage occurs, the registry data might become unavailable, and this is not automatically recovered. So customers who wish to have their registry data stored in multiple regions for better performance across different geographies, or who wish to have resiliency in a regional outage event, should enable geo-replication. So what is geo-replication? Geo-replication means that we have one copy of our data in a particular region. We have the replica of that same data in another region, so that in case of failure, we can back up the data from the other region. So in the here, instead of data, we have images. So geo-replication provides network close image storage or faster pushes and pulls in a distributed development or deployment scenarios. Then comes zone redundancy. Zone redundancy is a feature for the premium service type. Zone redundancy uses Azure availability zones to replicate your registry to minimum of 3 separate zones using Azure availability zones. So in each region, the data is replicated to 3 different zones, so that in case of failure, we can back up the data from the other 2 zones. Then comes scalable storage. Scalable storage means Azure Container Registry allows you to create as many repositories, images, layers or tags as you need. So up to the registry storage limit. So storage limit depends on the tier that you have purchased. If you are basic, standard or premium. Based on that, Azure Container Registry lets you create as many repositories, images, layers or tags as you want. So high numbers of repositories and tags, however, can impact the performance. So if you have a lot of repositories or tags, then the performance of the registry might decline. So to avoid that, we have to periodically delete unused repositories or images or tags. So there is one thing that we have to remember, that a deleted registry resource like repositories, images or tags, they cannot be recovered after deletion. So once you delete, it is for all. You cannot recover it back. Okay. Now comes building and managing of containers. So Azure Container Registry, as I have mentioned earlier, has got ACR tasks for this. So Azure Container Registry ACR tasks are a suite of features that will provide cloud-based container image building platform like Linux, Windows or AR. They can extend early parts of application development and can enable automated builds. So these automated builds are triggered by source code updates or update to a containers base image or timers. So based on the way in which Azure Container Registry tasks work, ACR tasks can be of 3 types. The first one is quick tasks. Then comes automatically triggered tasks. And then comes multi-step tasks. So quick tasks means that you can build and push a single container image to a container without needing a local Docker engine installing. So like you can push a single container to the registry, like using the commands like docker build to build the container image, and docker push to push it to a registry. Then comes automatically triggered task. That is, you can enable a trigger to build an image. It can be triggered on, like say, source code update, where the source code is updated, and comes a base image update, or on a schedule. So imagine you have changed your source code. Then you can set up a trigger so that a new image is built every time there is a source code update. Then you can also configure it in such a way that there is a trigger that will happen whenever the base image or the parent image or your previous image is changed. There is a change to that image. That means a new image is pushed to the registry, or the existing image is updated, or it can also run on a schedule. We can set up a schedule so that every 30 minutes or every other day there is a deployment or task that will happen. Then comes multi-step task. Multi-step task extend this quick task with multi-step, multi-container. So in quick task you can have only a single container, but in multi-step we can have multiple containers. So this is multi-step. Okay. So each ACR task has an associated source code context. That is the location of a set source files used to build the container image or artifact. So every time there is a change in the source code, you can set up a task to trigger. So to trigger a task on source code update, you can create Azure ACR task create. This is used to create a task. So you can specify a Git repository or optionally a branch in the Docker file. So let's say your main branch. So whenever there is a change in the source code of that particular branch, then what happens? The image is generated automatically, or the task is triggered. Then multi-step task use a YAML file. To why this YAML file is specifying the individual build and push operations. Can also define execution of containers. For example, you can create a multi-steps task that automates the following, like actions like build an image, run container, build a test image, run the test container, then build a Helm chart if this test pass, then perform a Helm upgrade. So what happens is that these tasks are executed sequentially. Then comes image platforms. So image platforms, by default, ACR task builds images for the Linux OS in the AMD64 architecture. But that is not all. You can specify the platform using the platform tag so that you can use either Windows or Linux images. For example, platform Linux ARM64 V8. In Linux you have AMD 64, ARM, ARM64 and 386. In Windows you will have AMD 64 architecture. So these are architectures of Linux. This one is for Windows. So a Docker file. Now we'll be discussing about Docker file. What is a Docker file? A Docker file is nothing but a script that contains a series of instructions. So these instructions are used to build a Docker image. So a Docker file typically have informations like base or parent image, commands to update the base, build artifacts to include developed application, services to expose, and commands to run when the container is launched. So for example, you can create a Docker file in this particular format. You can first use from you can specify the base image. So now this will be your base image. Then we can set up a working directory using work dir, and we can specify the path to the directory. For example, /amp. Then you can set up a command. For example, copy path of the published app to the current folder. Then you can use the command expose, and then you can specify a port number. So that documents what port the application expect. So like say expose port 80 means that it will be listening to the port number 80. You can to make the application accessible externally, you can also use the command docker run -p, have the host port, and then you have the container port. You can give something like 80 80 80. Okay, then you have a command to run, like for example cmd .NET. So we will be running the .NET command with when the container starts. So a change in this line will change the name and entry point to your app. So this line will be according to the entry point of your application. So the first command that you have to run to start up your application, that will be basically it. So that is all about Azure Container Registry. Thank you.